Work involving electrical hazards, Article 130. There were a few reorganizations that occurred here just because some of the information in 130 now found its way into 110. So there was a bit of a reorganization here, and that included some of the general requirements. This was reorganized and rewritten a little bit because some of this got moved to Article 110. What was 130.3 is now found in 130.1. And so just a bit of shuffling around here. With this one, when energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts are not put into an electrically safe work condition, and work is performed as permitted in accordance with 110.6, that used to be in 130, all of the following apply. Only qualified persons are permitted to work on the electrical conductors. An energized electrical work permit shall be completed, and the shock risk assessment performed, and the arc flash risk assessment performed. And so this is a lot of the same concepts, although some of this was reworded as part of the reorganization that has occurred. The shock risk assessment. So there was language that is part of the arc flash risk assessment that has now been duplicated, and what that language looks like right here. Estimate the likelihood and severity. The estimate of the likelihood of severity of injury or damage to health and the potential severity of the injury or damage to health shall take into consideration all of the following. Number 1, the design of the electrical equipment. Number 2, the electrical equipment operating conditions and the condition of maintenance. And so this is really to align it with what we already had in 130.5, because the same type of language exists for the arc flash risk assessment. But let's look at this. So we have item number 2, the condition of maintenance of the equipment. Well, okay. I actually took this photograph years ago, and if you were to try to make a judgment about the operating condition or a judgment about the condition of maintenance, I don't know. I don't think that would work out too well. So, you know, there's a lot that goes into this when you're trying to evaluate. Is there a shock hazard? Is there an arc flash hazard? I mean, for the shock hazard, if you look at this close enough, you'll see a few covers removed and things like that. I don't know if it's energized, but you don't know. I do have to give them credit for creative conduit routing. They made a very effective use of flex conduit for this one. Estimate the likelihood of occurrence of an arc flash incident for AC and DC power systems. This is new. This is a new addition. Some people have been talking to me about this, and let me explain what this is about. So we have these tables, and I mentioned the tables. The first sort of version of these tables were introduced in the 2015 edition, and it lists certain tasks. And then it lists, it didn't start out this way, but now it says likelihood of an arc flash, yes or no. And so there's a lot of different tasks in there. And in general, if you have equipment where all the covers are in place, normal operation, and just operating it, it's considered basically not a high likelihood of an arc flash. But there's one in there now that is. And it's the one that was introduced for 2021. And so what this looks like, if you're going to operate a circuit breaker or a switch for the first time after the installation or completion of maintenance in the equipment, the first time operation. Why is that? Well, I don't know if any of you have heard of the smoke theory of electricity. You could do a web search for it. It's actually there. It's kind of a joke, but all things are powered by smoke. So I have worked with people in a past life, back actually in the late 1970s, that they subscribed to the smoke theory of electricity. And their way of checking a circuit is, oh, we did okay. Let's just throw the switch. If we see smoke, then we know we got to go fix something. No. You know, is there a huge likelihood when you energize a breaker? Well, I can't contradict this, but within NFPA 70E, the rationale is yes, the first time you're operating a circuit breaker or a switch, after its installation or after completion of work or maintenance. Over on the far right, likelihood of occurrence of an arc flash? Yes, that is a new change to the 2021 edition of NFPA 70E. I want to look at incident energy analysis next, because this is going to go into the next few subjects. So the concept of an incident energy analysis is, number one, you calculate or estimate the prospective incident energy, the severity of the arc flash. And then you select PPE and clothing with an arc rating sufficient for the incident energy. Simple enough. The incident energy analysis in most parts of the world, if this is performed, is based on IEEE 1584. The second edition of this standard came out in 2018. If you don't have a copy, you can go out to techstreet.com. That's actually the organization that IEEE uses for the delivery of the standards. And you can order your copy of it out there at TechStreet. But IEEE 1584, it has its origins. The 2002 edition is the one that really got things moving. It was a standard based on empirically derived equations. And then we have the 2018 standard. So this is part of the incident energy analysis, and it wouldn't be complete if I didn't have at least one video showing an arc flash. And so this video that you're about to see is an arc flash that I staged. It was part of a pretty big project years ago. It was 50,000 amps of short circuit current, 480 volts. It was a really large switchboard. So let's see what this looks like. I wouldn't want to be standing in front of that, but that's really what the incident energy analysis is all about. It's actually predicting the severity of an arc flash for a given set of variables, and then selecting protective equipment, protective clothing, arc-rated equipment that can protect you from the incident energy from the arc flash. Now, why am I talking about this? Because there were some changes along the way. Some of these changes, there was an informational note that was added. So what we have is there's table 130.5G, and this is actually for selecting PPE when the incident energy analysis method is used. There's a table for selecting PPE, and I'm going to show you kind of an excerpt of it. There were two changes made to that table. Similar changes made to the NFPA PPE category table. So both have this similar kind of a change. And so this first change is if you're wearing arc-rated PPE like this, this is a 65 calorie PPE. So if you're wearing arc-rated PPE and you have the need to wear an outer garment, either for weather to protect you from the elements, or maybe for safety, like a high-vis vest or something like that, what this is designed for, this new informational note, is that you can wear those types of garments as long as they have an arc rating, and the arc rating doesn't have to match what your actual protection requirement is. So the objective is, if there is an arc flash, just to make sure the garment doesn't ignite and keep burning. That's what it's all about. This is actually your primary protection. So there have been a lot of questions about that over the years, and that was a change that was made to the 2021 edition of NFPA 70E. So it actually specifically reads, the arc rating of outer layers worn over arc-rated clothing as protection from the elements or for other safety purposes, and that are not used as part of a layered system shall not be required to be equal to or greater than the estimated incident energy exposure. So that's new. That's one of the additions. Another is about footwear. In the past, it's been permissible to wear leather footwear or dielectric footwear, and that was really all that was mentioned. And now there's an informational note that states footwear other than leather or dielectric shall be permitted. So you can use footwear other than these two types. Permitted to be used, provided, oh, there's a catch. It's been tested to demonstrate no ignition, melting, or dripping at the estimated incident energy exposure. And so that's a new informational note also added to the table for selecting ARC-rated clothing and PPE, and also for the PPE category table. Where we have that is right here. This is for the incident energy analysis 130.5G, and there's a whole lot more than what I'm showing right here. But this table is broken up into the PPE up through 12 calorie per square centimeter, and then at the bottom greater than 12 calorie. And so now for the ARC-rated outerwear or high visibility apparel, they used to have the word safety in there, that was removed. Down at the bottom, that's where you're going to find the note about the ARC rating of the outer layer worn over the ARC-rated clothing as protection from the elements or for other safety purposes and that are not used as part of a layered system shall not be required to be equal to or greater than the estimated incident energy exposure. That would have just been difficult. If you're wearing like a 65 calorie system, how do you get a high-vis vest to have that kind of a rating? Then we also have the reference to leather footwear. This is where we now have the ability that you can wear something else if it's been tested to demonstrate no ignition, melting, or dripping at the estimated incident energy exposure. This might look familiar for some of you. If you look closely at the label, we have an incredibly high incident energy. This is an age-old problem. This one, it's over 130 calories a square centimeter. I'm sure many of you have run into this. Normally, what causes such incredibly high levels of incident energy is the arc duration. It's not that the arc would last like forever, but the calculations will sometimes indicate that. And actually, this particular piece of equipment, this is a service switchboard. So the device that's going to, we'll call it limit the arc duration, it was the utility company fuse on the primary side of a transformer. And in that kind of condition, a lot of times if there's an arc flash, the arcing current, that type of device may take until like next Tuesday before it decides to operate. So as a result, you have this really long clearing time. But there's a problem because people will recognize, well, we need to de-energize. We need to establish an electrically safe work condition. Well, that's correct. That's what you need to do. The problem is, in establishing the electrically safe work condition, one of the last steps is you go verify that it's de-energized, electrically safe, the absence of voltage. And until you've verified that there's an absence of voltage, you treat it like it's energized. Well, if you have 130 some calories, what are you going to wear for that? And this has been the age-old problem. And so there is new language within NFPA 70E to address this particular problem. It's the case where you have to wear arc-rated PPE to verify the absence of voltage, but the incident energy is quite high. So there is a new informational note that was added, and it states what we run into, where the estimated incident energy exposure is greater than the arc rating of commercially available arc-rated PPE. Then for the purpose of testing for the absence of voltage, the following examples of risk reduction methods can be used. First off, I want to mention PPE. The arc ratings have been going up considerably. This one on the right, that's actually my hand holding it up. It almost stood up by itself. This is an arc rating of 140 calories. And so arc ratings continue to increase, but not everybody has access to this kind of PPE, and you can still have incident energy levels above these values. So what are the risk reduction methods? Well, you can use a non-contact instrument to check and see if there's a voltage there, or measure on the secondary side of a voltage transformer. Some of us know it as PT, potential transformer, but voltage transformer, before you use a contact test instrument. So you're basically giving kind of a trial run here before you actually make contact. Another method, look for the visible gaps with the conductors. That'd be like a switch. You open, if you have access to actually look at a switch, is the switch open before you use a contact voltmeter. Increase the working distance. Now the working distance is really critical for a lot of this, because the working distance, when someone calculates the incident energy, it's actually based on the distance from the source of the arc flash to the worker's torso and head. And so increasing the working distance, if possible, that may go a long way towards helping out. Another example of risk reduction method, consider different design options. Maybe use some type of current limiting type of a device. And remember, I mentioned IEEE 1814. That's going to be coming in, and that's going to give us some options. Another change to the 2021 edition. We have a table, one table that now is part of a pair of tables. We had table 130.7C7. That was for rubber insulating equipment, the maximum test intervals. That is now 130.7C7B. And we have a new table. That is table A. And table A is for the maximum use voltage for rubber insulated gloves. And what that table looks like, and notice my note down at the bottom, this is just for discussion. You actually need to use the actual table from NFPA 70E when that comes out. But this shows the different classes of gloves and then the voltage ratings. And on the right, the distance between the gauntlet and the cuff, the minimum distance. So that would be like when you have your voltage rated glove and you have your leather protector, the distance from the gauntlet and the cuff. Right in here, there's a certain minimum distance that's required. Usually you far exceed it, but there is a certain minimum distance for that. And then the original table, that's just been given a B designation, 130.7C7B, so that is still there. This was another change. I actually got kind of involved in this one. For PPE, testing and ARC-rated PPE, historically, NFPA 70E has referenced ASTM standards. And the last cycle, all of those standards were moved to a table referenced by an informational note. They were basically taken out of the mandatory part of the text. One of the things that happened during this, I'm an ASTM member, although I'm not as active as I should be. One of the things that happened was at the top level of this ASTM committee, they sent out an email like, oh, great. You know, there was a lot of heartburn over this, moving it out. And there was a statement made about next thing you know, we're going to be using IEC standards. And well, being chairman of all those standards, I had to put on my official IEC hat and fire back. It's like, wait a minute. IEC standards are just as good and maybe even a little more stringent than ASTM standards. But what happened along the way is, guess what? 2021, the IEC standards have made their way into this. You notice 61482-1-1, that's the actual test method. And the one thing that's different between ASTM and IEC is we have what's called ELIM, E-L-I-M. That was to, well, I won't go into the details, but that was to satisfy certain European-specific requirements. And it can be a little bit more stringent than the standard testing. This is actually the standard, one of the standards right here for testing, but it's very similar, maybe slightly more stringent than the ASTM standard. And in fact, the test setup, this is the test setup. This was in Geneva, Switzerland. I was there recently. And if you look at the test setup, and there's a couple labs that'll do this. Big one is actually in Canada. There's a lot of testing there. So this is a calorimeter that measures the energy, and then you have opposing electrodes where you put a trigger wire, and then that initiates the arc flash right there. And then you have the fabric samples of the garments on the panels that are spread equidistant around there. Article 360, I mentioned this a moment ago. Brand new. Capacitors were only referenced a couple of times historically in NFPA 70E, but they are a large source of stored energy and quite a source of a potential hazard. And so there is a new article, it's actually quite large, that is broken up into scope, definitions, and then the stored energy hazard. That's really important. And measures for personal safety, establishing an electrically safe work condition that's specific for capacitors. It's not like what we'll call a traditional electrically safe work condition. There are other considerations that need to be made, and the use of grounding sticks.